Good evening, class. Today I will be covering a topic in Chapter 5, that's gases and pressure. So what I'll be doing is demonstrating our ability to measure blood pressure using gas and pressure. So basically the first question I have is a question I want to put in your mind as I go through the demonstration is, how is gas and pressure used to measure blood pressure? So first I'm just going to draw a little mercury column here. This is the typical column that we used to use. They're hard to find now. So and the blue line represents the mercury on the column. So typically you have a high number. Let's just put 180 up here at the top, and we'll put 60 down here at the bottom. And that's typical, the old mercury column that's used to be used, but now they're not widely used anymore. So I'll go ahead and demonstrate what the manometer looked like. So basically this is the only thing you see is the front side of the manometer, but on the inside this is what it looks like. So basically a manometer is a U-shaped tube, and it is filled with liquid. So in my case, for my demonstration, that liquid is mercury, and mercury is periodic symbol is Hg. So I'll go ahead and fill that tube with mercury. Line here, line there. So at the top of the mercury on each side is the surface line. So we'll go ahead, and that's where the pressure is. So we'll go ahead and name the left side P1, the right side P2. So right now, as it's depicted, we can say that P1 is equal to P2 because the surface line is the same all the way across. So what we'll do, so let's say that we increase the pressure on P1 and decrease the pressure at P2. So that surface line for P1 should decrease. It should decrease. And the surface line for P2 should increase. So we'll go ahead and make that change. And I'll go ahead and demonstrate the change in the surface line. So this shows that the pressure is greater on this side. So whichever surface line is the lowest has the greatest pressure. And also, this surface line on the left side has a correlation all the way across. So what I'll do is draw that with a dotted line all the way across to show that correlation on this side. Now, there's pressure in the fluid, in the mercury, and there's pressure on top of the mercury. So we can say that P, pressure, and we can go ahead and determine whichever side has the lower fluid level has the highest pressure. So again, so we demonstrate that pressure 1 is equal to the pressure in the mercury. So notice that this is causing some pressure through the mercury again and on the mercury. So we'll go ahead and we will say that to find out what the pressure is, we can say P1 is equal to the pressure in the mercury plus the pressure on top of the mercury. So the pressure of P1 is equal to the pressure going through the mercury and the pressure on the mercury. So basically this gives us the baseline mechanics of manometers, a manometer, and its relation to how it works. So I'm going to erase this, and then I'm going to go to the next step. So I want to ask this question. So how does the manometer help us in relation to knowing what the pressure of blood is. So we'll put this problem up. So let's say that if we subtracted P2 from both sides, we can say that we can see what the pressure of the mercury is. So let's write that up on the board. That is going to be pressure of mercury equals P1 minus P2. And that formula will give us the pressure from the mercury and the pressure from P2. So remember, that pressure is over an area when you're measuring blood pressure. So we'll go ahead and demonstrate that as area pressure. Okay? So what I'll do now is I'll erase this, and then we'll move on to the next step. So we're going to keep our manometer, and we'll use that for the next demonstration. So just to keep in mind, let's remember that pressure is, we'll write the formula out for pressure, which is P is equal to force over area, or it can be written as force over area. So that's the basic formula that gives us the ability to calculate, or the manometer to calculate the pressure in blood as it moves through the arteries. This is typical to what we would see in a mercury column in regards to blood pressure. So we'll go ahead and erase that. We'll take all that off. My beautiful drawings. Okay, so next, I'm just going to talk a little bit more about blood pressure. So let's say that the normal blood pressure is 180 over, no, excuse me, that's incorrect, that's 120 over 80. So 120 over 80. So the top number is our systolic. That's the first sound that you hear when you're listening manually for blood pressure. And the bottom number is the diastolic. And that's the last sound that you hear, excuse my writing, but that's the last sound that you hear as the sound fades and you're listening for blood pressure manually. So next, what I would do is just demonstrate how the mercury column works. So it's basically a tube, and it is filled with mercury, and it's turned upside down. Surface line. So at the top up here you have a vacuum. It creates a vacuum from it being turned upside down, kind of similar to you taking a straw and filling it with fluid and you put your finger over the top. So the units that we use to measure blood pressure is millimeters per mercury. Okay, so millimeters per mercury is just a unit to describe pressure. Another common way to describe pressure is ATM or atmosphere. So that's another common way. So we'll move back over here to the picture, and once the tube is turned upside down, as I said, it'll create a vacuum. So what we have here is a tiny pool of mercury here in the bottom. We have a tiny pool of mercury, and we have our tube of mercury that is flipped upside down, and we have a vacuum at the top. Where it stops, to the bottom, the pool is always 760 millimeters per mercury. Write that again over here. 760 millimeters per mercury. All right. So, and that's always going to, and the reason why that's so is because it actually stopped at 760 millimeters per mercury because the air pressure pressing down is enough to balance out the gravitational pull of the mercury wanting to come down at that point, which is basically at sea level. We have 760 millimeters mercury. So next, what I'll cover is the height. So that's the height here, and as I said, that height is in relation to sea level. So it'll always be 760 millimeters mercury. All right, so we will erase that. And now that we've covered that, we will demonstrate how that works. How that works in relation to the blood pressure cuff. So here we have an artery. So this is my artery, and we have blood inside of that artery, and we have pressure pushing out against the artery every time the heart beats. We have pressure pushing out. So remember that pressure is measured over the surface area. So remember this pressure is P to the force area. So when you think about that, think about having a blood pressure cuff wrapped around that vessel, just say at the site. Let's say you're using the brachial artery and the bend of the elbow. So this is what the actual apparatus is measuring. That force that's pushed out against the artery walls as the heart pumps and relaxes. So earlier we talked about the normal 120/80, so that's just a radius. So there's a lot of other things going on in between that 120 and that 180. So that number you get is just not 120, it's just not 180. You got all other things going on in between, which is another class. So we won't cover that now. So the way that blood pressure is calculated is, again, it's the force over the area equals blood pressure. So using the apparatus to measure the pressure, that's how we get it numerically. So you have a force that that's being asserted against the walls and the arteries, and the pressure being measured by the manometer. So that's, in short, in essence, how the manometer gives us the ability to measure blood pressure. So what we'll do right now, we'll just recap what we did cover. Take that down. And so now we will just recap what we went over. So again, covered chapter 5, which was gases. talked about is the manometer, which is a apparatus that is used to allow us to gauge pressure. And it can be used different ways, whether that's atmospheric pressure, blood pressure, or other pressures. So we talked about the manometer, how it works in relation to reading the pressure of the blood when there's a certain pressure against the artery walls. And we talked about blood pressure as far as the first reading that we get and the second reading that we get, which is the systolic and the diastolic. And we also talked about how the pressure works internally inside of the manometer to give us that ability to gauge the pressure in blood. So this concludes my briefing today on Chapter 5, Gases, and I hope that you enjoyed this lesson.